let's get started, everyone. We are working on finding limits at infinity, and we've already done, as a quick recap, we've already done ones with polynomials. You know, something like that. And we've looked at how you would do them. Yeah, when they have square roots, and hopefully we've covered those two situations and you're quite comfortable with them. I won't do the whole question, we'll just talk about the start of it. I've made these relatively simple ones. Biggest power on the top is x cubed, biggest power on the bottom is x cubed. You divide both by x cubed, and then you brute force it and you'd get 3/4. Would you agree you can look at that question and tell the answer is going to be 3/4? Can you tell how I can tell it's going to be that number? Does that help a little bit more now? So, knowing that the answer is 3/4 and proving that it's 3/4 are not the same thing. So, in WebAssign, you might well be able to do a lot of these questions really quickly because of that. But I strongly suggest that you do the working for it anyway, because that's what you're going to be asked for in the test. This guy here is the square root of 2x squared, and the guy in the bottom is 3x. What do I divide the top and bottom by in that question, that situation?
You divide the top by square root of x squared, and then divide the bottom by x because it's the same thing.
Yeah, pretty much. Couldn't have said it better. Exactly. Are we comfortable with that? Are we also comfortable that sometimes there's a difference in the power on the top and the bottom? Like there might be an x cubed on the top, but only an x squared on the bottom. And in that case, the rule is to always divide by the bigger power, which is x cubed. Right. So when you look at the numerator and the denominator, you're going to divide top and bottom by the same amount, and that power of x that you use is the larger of the two powers. Now, I guess this would be a point for me to tell you, you can look up YouTube videos and you will find that some of them change my rule. And when you have an x cubed on the top and an x squared on the bottom, they tell you to divide by the smaller power of x. And that also works. And so if for some reason that kind of makes sure that works better for you, then you can do it. As long as it's the same thing top and bottom, it pretty much will come through. Now, let's look at this situation. And we're going to be looking at how to find the limit as x tends to infinity of this. Now, it doesn't have a polynomial in it, which makes it a little bit different. But I'm going to use a technique very similar to what we would do. I am going to divide the top and bottom by something, the same something. There's not an awful lot of choices, really, if you think about it. What do you think I might be dividing the top and the bottom by?
E to the x.
Right. Now, let's see why that, well, let's see where it goes and then why that might be a good idea. So this fella is going to be 4 over e to the x, take away 2. And this guy is going to be 5 over e to the x plus 4. And I'll have to squeeze in my limit as x tends to infinity. And we got that. Now, normally what we would do with a polynomial after this is brute force, right? We just put in infinity. So let's see what happens. And I'll kind of write an extra line for maybe for this time. Probably won't do it all the time. Okay, e to the power of infinity. Is it not infinity? And what's 4 over infinity going to guess?
0.
Agreed.
Small
So
number.
can you see 0 take away, 0 add, final answer, negative half. Do you see it just work? So it's really the same technique, isn't it? Just for a different situation algebraically. Are we happy with that one? Do you need to see another one of them? Or are you good? We're good. Let's move on. The next situation I'm going to kind of deal with is what is, well, it depends where you read. It's called the squeeze theorem. It's the most common name for it. So that's what I'm going to use. And it's used to find limits of, well, let's give you an example of it. So this one, for instance, is very similar to question 21. There's not many like this. In fact, I think there's only 2. Yeah, there are only 2 of them. So here is an example of a limit as x tends to infinity. And we're going to use a technique, a new technique. So this is different from what you're seeing, called the squeeze theorem. So, first mathematician in the world was given this problem. Well, I guess I could just plug it into Desmos, couldn't I, and just look at it. I could be able to tell if it flattened off at 0 or shot off to infinity, right? I could probably do that. But we're trying to figure out how we could prove that it's equal to that. Anybody get any ideas just off the top of their head what the limit of this would be? Any ideas?
Infinity?
Could be. What's another possibility?
Negative infinity?
Oh, because of this? Yeah, I guess so. There's one last possibility that you haven't mentioned yet.
0?
Yeah. Let's find out which of those it is then. First thing I'm going to do is a piece of algebra. Are we comfortable with a negative power being written as a fraction with positive power in the bottom? So essentially that is in. You comfortable with that? Now, why can I write that this limit has to be less than or equal to that limit?
Because sine has to be less than 1 or greater than negative 1.
Okay. And since you said the greater than negative 1, let's put it on this side. So the squeeze theorem, another name for this is the sandwich theorem, but I like the squeeze theorem name. Can you see the answer I want is squeezed or sandwiched between 2 other limits? Now what I'm going to do is I'm going to find what this limit is. Well, I can just do brute force, can't I? 1 over e to the 3 infinities. Well, that's 1 over e to the infinity. Don't know if I need this many lines. Would you agree it's 0? This limit here is 0. Now, if you do a negative 1 version, it's this fella, which is negative 1 over infinity, which is also 0. So what we now have is the limit I'm trying to find has to be between 0 and 0. There's not an awful lot of room there, is there, for what the answer is going to be. Therefore, the answer is 0. So out of all the choices that we came up with, it ended up being the 0 one. It's a very, very specialized proof. Would you agree? It's not something, there's only 2 questions, right? It's not something you're going to do a lot of work with. And so it's one of those things that it's easy to miss it out. Do you want to see the second one, or is one of these good enough? You want to see the second one?
Yeah, I would like to see a second one, especially if you're going to have sines and cosines and tangents and stuff in there.
I gotcha. Okay, the other one is in the homework. It's question 22. This is going to be like a version of it. Again, it's the limit as x tends to infinity. This time it's going to be sine squared x over x squared plus 4. And if I'd thought about it, I would have written it a little bit lower so I could get some room. Okay, let's look at what this could be simplified down to. Essentially, what you do is you get rid of the trig. Okay, what do I know about sine x? Well, it can only go from -1 to +1, right? Isn't that also true for sine squared? Well, not quite. Sine x can go from 1 to -1, agreed? But sine squared x can only go from 1 to 0. It's not that big a deal, but would you agree that sine squared x can't be negative? And would you also agree that it can be 0? So 0 is the first number on the left, right? The first positive number it can be. So in this case, it's going to have a 1. And on this case, it's going to be the limit as x tends to infinity of 0 over x squared plus 4. Now, brute force it. Well, let's take a look. 1 over infinity squared plus 4. Would you agree that infinity squared plus 4 is infinity? So on this side, it's 0. And this one's silly. Isn't 0 over infinity definitely 0? And so the guy that we're wanting to find the limit is, yet again, 0. The typical questions that involve you using the squeeze theorem have a sine or a cosine in them, or a sine squared and a cos squared in them. And the vast, vast majority always end up being 0. Just, you know, you kind of see why 0 is probably going to be the go-to answer. But that's essentially how this works. Are we good now? The kind of theme now that you seem to?
Yeah, thank you.
Right. So think of sines and cosines as being 1s and -1s, and build a left and a right, and they'll zoom in together and squeeze the thing into nothing. Okay, we have got just one last little thing to do. And these are very small questions as well. Here are some examples of them. None of these are fractions. We're being asked to find the limit as x tends to infinity of a polynomial, negative infinity, another polynomial, a trig and an e to the x, and a radical and a polynomial. And in these questions, you are not really going to prove what the answer is. You're just going to find the answer. You could simply just, as always, couldn't you plug them all into Desmos and see what they look like? You know, does it level off at a number? Does it shoot off to infinity? Does it level off at 0? Does it shoot downwards to negative infinity? I mean, what does it do? But we're going to show you that you can actually get the answer very quickly by just using a kind of hierarchy. What do I mean by that? Technically speaking here, I have infinity cubed plus 2 lots of infinity, right? So if I just do brute force, I have infinity cubed plus 2 lots of infinity. Would you agree that in this question, infinity cubed is much more important to the final answer than the other 2 lots of infinity? So in this case, they're both going in the same direction. Would you agree plus infinity is the answer? Well, what would it be then if I gave you x cubed, take away 2x? Well, it would be infinity cubed, take away 2 infinities. I know the answer is not 0. Some infinities are bigger than others. Isn't infinity cubed bigger than 2 infinities? So think of a little battle going on. Who wins the battle? Who is going to be by far the biggest number at the end of the day? Would you agree that this fella here takes priority, and so the answer is still going to be plus infinity? Okay, if you were doing an x cubed, a 2x squared, and a plus 1, which one of those 3 is the only one that really matters as far as the limit tending to infinity would be?
X cubed.
So, you say it, Robin?
X cubed.
Agreed. Now, in this case, did you notice I did negative infinity? So it's going to be negative infinity cubed, right? What do you know about that guy? Isn't that negative infinity? Oh, by the way, all these questions are going to be plus or minus infinity. You're not going to have, tending to 2 or anything going on. Right. Sine x plus e to the x. Who do you think is going to win the battle of who's the biggest?
E to the x.
And so won't the answer essentially be positive infinity, because e to the infinity is infinite? Who's going to win between square root of x and x cubed?
X
X
cubed.
cubed.
Right. And there is a negative in front of it, so negative infinity cubed ends up being negative infinity. Are we good with those questions? So the biggest of the terms, right, the one that's going to be the most important, is the only one you need to focus on. Then make x infinite and do, I guess for want of a better word, an infinity calculation. Like minus infinity squared is plus infinity, but minus infinity cubed is negative infinity. You kind of know the answers are going to be infinite, these kinds of questions anyway. So you don't have too many choices, right? So you just really want to make sure you pick the right one of the 2. Are we good with that? We have reached a kind of very interesting point. I'm now going to start the tangent line problem again. We are going to find the exact value of the slope of a tangent line at any point on the curve, any point on the graph. We are going to start finding derivatives. That's what you call when you find the slope of a tangent line at a given point, you're finding the derivative at that point. That's just the word that we use to describe that. So let's return to the tangent line problem and show you how we're going to approach that. Green. Here is the function I'm interested in. And I'm going to make this as general as possible. So I'm going to choose a point A, right? So when x is equal to A. And at that point here, right, we're going to have P, right? That guy there. And P has coordinates A, comma, f of A. Agreed? If its x coordinate is A, won't its y coordinate be f of A? And then we're going to do, don't know what colors I'm up to here, a line that should be the perfect tangent line. And that's the guy we are going to find the slope of, right? So how's that going to work? Well, I am going to choose another point and I'm going to call it A plus H. And I want you to think of H as being a very tiny number, you know, like 0.001 kind of number, right? And this guy is going to get me to here, and that's going to be Q. And Q is going to have coordinates A plus H, comma, f of A plus H. And I'm going to find the slope of the tangent line joining P to Q. Right, so there's P, there's Q, and I'm going to find its tangent line. I wish it was a bit steeper, but that's fine. Now, if you want to find the slope of a tangent line joining 2 points, and point P has coordinates A, f of A, and Q has coordinates A plus H, comma, f of A plus H, then the slope of the tangent line from P to Q is the rise divided by the run. That's the y coordinate of Q, take away the y coordinate of P, over the x coordinate of Q, take away the x coordinate of P. The y coordinate of Q is f of A plus H, and the y coordinate of P is f of A. The x coordinate of Q is A plus H. Take away the x coordinate of the other guy, P, and that is A. And there's not much going on, but there is a little bit of cancelling. And so we get to this. That the slope of the line, it's called a secant line, P to Q, is given by this formula here. So you might say, well, how is that going to get me the slope of the tangent line? Well, hang in there. Here it's coming. The slope of the tangent line. What happens if I make H get smaller and smaller and smaller and smaller? In other words, what happens if I make the limit as H tends to 0? won't this slope become the tangent line? I'm not making them equal to 0. Do you notice I'm using limits? I'm saying its limit as it becomes closer to 0, right? And what you now have is a way to find the slope of the tangent line. It's the limit as h tends to 0 of f of a plus h, take away f of a over h. And that will work for any function in the universe as long as it's differentiable and you have enough algebra skills to deal with it. Now that's totally general, right? There's no particular function I've mentioned, no particular point in the curve, but that's going to be our go-to guy. There are two of these guys, but that's one I'm going to be using probably most of the time. So let's take it.
So,
And
excuse me, I
yes.
got a question. So a secant line has to cross 2 points and a tangent line only crosses 1. So you
Yes.
can't, at that point, are you saying they're both equal? They're the
Yeah.
same?
I'm saying their limit is the same.
Oh, the limit is the same.
You can't make them equal because if you make them equal, you get 0 over 0 and all the mathematicians start screaming again. But you can make the limit as h tends to 0, can't you? We know how to make that happen. So it might be a kind of workaround, but it works really well, so we're glad. Okay, let's suppose I had x squared plus 2x plus 3, right? And I would like to find the slope of the tangent line, and I'm talking about the exact answer, right? The exact slope of the tangent line at, say, x equals 4, right? So far, so good. Yeah, how do we do that? Well, you find the limit as h tends to 0 of f of 4 plus h, take away f of 4 all over h. Because when you want to find the tangent line at x equals 4, aren't you really saying at x equals a? Right? In my picture, wasn't a the place you want to find the tangent line? So when you're thinking, how am I going to use this formula? A is going to be the x coordinate of the point you're trying to find the tangent line for. Now let's see what this looks like. It's going to be the limit as h tends to 0 of this guy with a 4 plus h in it. Somewhere in Math 141, you had to do a guy that looked like that. And I told you when you were in 141 that you are going to use that guy in calculus. You are now about to use this guy in calculus. That's him there. Right, so let's see what the value of the function at 4 plus h looks like. It's instead of x squared, it's 4 plus h squared. Instead of 2x, it's 2 lots of 4 plus h, and then it's an add of 3. Right, that's the first guy. Take away. Isn't f of 4 just a number? So what's that going to be? It's going to be 4 squared, which is 16. 16 add 8 is 24. Add 3 is 27. Four plus h, if you FOIL it out, you get 16, you get 8h, you get h squared. 2 lots of 4 plus, you get 8 plus 2h. And you have an add 3, and you also have a take away 27. And the whole thing is over h. This guy plus this guy plus this guy totally kills off that guy. So the 27, take away 27, all the numbers have disappeared. So what we are looking at now is that. If you do this correctly, you will always get to a place where there's only terms with H's in them. If you've got a +7 or a +2 or something left over, go back and do your math because you've missed something. Is there anything I can do? And I'm taking this one really, really slowly. Is there anything I can do at the top line to make it prettier?
Combine the 8H and 2H.
Think factor and cancel here. Is there anything I can do to the top line?
Yeah,
That's gonna
you can factor out an H.
and cancel, right? I'm running short of room, so I'm going sideways now. And isn't that a very easy limit to calculate? Can't you just plug H equals 0? And the final answer is 10. I can now tell you that the exact value for the slope of the tangent line to this quadratic at x equals 4 is 10. Not my best guess that it's 10, or my estimate is 10, or fingers crossed, I hope I got lucky, it's 10. It's 10. And the way we got round you can't make P and Q the same point, which is where the problem started way back in week 1. Remember, if you make P and Q the same, you get 0 over 0 and you're stuck in determinate form. We now have a strategy that uses limits. So if you're wondering why we spent all that time on limits, it's so that we could get really good, hopefully, at finding exact values of tangent lines using this formula. Let's try another one.
I have a question about
Yes.
that. Will it always cancel out as far as the numbers go for how 16, 8, and 3 cancel out 27?
Yes, always. And if it doesn't, you screwed up somewhere. Figure out what you didn't do right, because they always do. They always disappear. And it's maybe it's surprising that that's going to happen, or maybe it's kind of cool that that's going to happen, but it's going to happen.
Okay.
At least for the ones you're going to see. The technique that we're using is pretty good for polynomials, and I'll be showing you square roots and fractions. But this is kind of an intermediary stage, because it's a lot of work, isn't it, just to find one answer. And if I wanted to know what the answer was at x equals 7, wouldn't I have to go through a whole different, very similar looking, but a whole different question as well. And we're going to eventually show you that this intermediate stage is like just so that we can then show you the shortcut. And then once we show you the shortcut, nobody does it this way anymore. But we kind of can't jump from question to shortcut without a kind of bit in the middle that kind of convinces you that the shortcut actually is reasonable, right? Otherwise, it's just magic. You know, you do it because I told you to do it and it works and okay. So let's try x cubed. And I'd like to know the exact value of this tangent line. Right, we sometimes use this notation. You say it as f dash 2. Unless you are Americans and you call it f prime 2. But I'm not an American and I refuse to do it. So it's f dashed 2. And when you get other calc classes, your professor will know that you got me because you hopefully will say f dash 2 as well. Some of you might even say Z sometimes. I'm taking that as a victory, right? So F dash 2 is what it is. And what does that mean? Well, that just means the slope of the tangent line at 2. Would you agree that's a lot easier than having to write that English every time, right? So F dash 2 just means the slope of the tangent line to this particular function at 2. So let's find out what that is equal to. It's the limit as h tends to 0 of 2 plus h. Take away f of 2 over h, right? Well, the general formula, right, the one you can use all of the time, is this guy, right? You see, I'm just replacing the a with 2, right? That's all I'm doing. Right, 2 plus h is 2 plus h cubed. Take away 2 cubed all over h, and I forgot my little limit thing, so I'll squeeze it in here. So it's going to be the limit as h tends to 0. And you're going to trust me on this. You get 8 2h squared. No, you don't. No, you don't. You get 6h squared plus 6h plus h cubed. There you go. Let me be 100%. I want to tell you something then. 2 plus h cubed, 2 plus h times 2 plus h squared, 2 plus h, 4 plus 2h. Yeah, I'm glad I did this. And h squared. That's going to get me 8, 4h, 2h squared. And then I'm going to get 4h, 8, 4h, 2h, so 4h, 2h squared, and then h cubed. So I'm going to get an 8. That one I got right. 8h, 4h squared, h cubed. So it's the limit as h tends to 0. Oh. It's not meant to be that hard, but I'm making it hard because I am. It's going to be 2 cubed. It's going to be 4. Gives me 12 of these.
It should be h6 cubed or squared and then 12h and then just h cubed.
Okay, you want to just say that again for me from the start?
So 8 plus 6h squared plus 12h plus
Okay.
h cubed.
So the guy I got wrong was
That's what I
basically
got.
The
that.
12h, yeah.
Right. So, as I say, it's not meant to be as hard as I made it. For some reason, my brain can't work. The only guy I'm comfortable with is, you see those 8s cancelling out again? Right, we mentioned the numbers always go away. In this particular question, that's really the only major issue. This is what's left. Now, what you'll also get is pulling out a common factor of h. So just like the numbers always cancel each other out, you'll always be able to pull out a common factor of h, which means I can now cancel these guys, which is the limit as h tends to 0 of 6h plus 12 plus h squared. Right, if you make h go 0, don't you get 6 lots of nothing plus 12 plus nothing squared. So basically you get 12. Are we comfortable with that? Okay, a little hiccup because I can't cube things anymore. Right, apart from that, it worked good. I want to show you a little thing that you can do in your calculator as a backup, not as a replacement, but as a check. I'm putting an x cubed here into my calculator. I'm going to go to the window. Since I'm interested in the slope of the tangent line at 2, just pick a window that's got 2 in it. So 0 to 3 works fine. And then if I do zoom 0, I'll see the piece of the curve. It's pretty boring, right? It's just a curve. Now you go second calc. And there's a guy down here that uses funny notation. It's called dy by dx. And we'll talk about that notation in a different day. But it basically means the derivative, right? Now, if I hit that, and then I type in 2, I should get 12. Okay, would you agree 12.00001 is 12? Right, is that kind of, I don't know if it proves, but isn't it a check that it's 12? Now you might
Show me
think,
that again, by chance.
second calc, choice number 6, type in the x coordinate, in this case 2, press enter. And the slope is 12 point, lots of zeros and ones. If you're wondering where's all those zeros and ones come from, you know this is a calculator, not a human. It doesn't know how to do limits. So do you know what the calculator probably did? It probably did a line from 2 to 2.00001, and then the answer came out. You know, isn't that kind of what would happen if you did it numerically? Wouldn't you'd guess it was 12, but there would be a little 0.0001 left over or something like that, which you would say isn't really a problem. So it is a good check. Do you feel comfortable about how to use this new guy in town that's going to give us the exact value for a slope of a tangent line? We've basically solved the tangent line problem. We found a technique that allows us to get any curve you like, as long as the algebra can be handled, right? Typically, the only ones that are really feasible, i.e., doable in a reasonable amount of time, are polynomials, simple fractions, and square roots. And no. Okay, I'll go for it. I was going to say no. Let's do a square root. Okay, can we do this guy at 4? Because 4 is a nice number for a square root, would you agree? I don't want to do it some weird number like 17. So let's find the slope of the tangent line. So f dashed of 4, the exact value for the slope of the tangent line at 4, is going to be the limit as h tends to 0 of f of 4 plus h, take away f of 4 all over h. We're happy about this guy with 4 instead of 8. Right? Instead of a plus h, 4 plus h. Instead of take away a, f of a, it's take away f of 4. Now that becomes the limit as h tends to 0 of the square root of 4 plus h, take away the square root of 4, which is 2, all over h. Now, what technique am I going to use to find this one?
Conjugate method?
Conjugate. Can you see why we learnt the conjugate method? Yeah. So, to remind you, it's the same two guys, but with a plus, right? Same two guys, but with a plus. Now that's going to be the limit as h tends to 0. As always, I don't really do anything to the bottom. And if you multiply the top, you get the first guy squared, right, which is this. Take away the second guy squared. And it's just so elegant how this works out. Do you see the numbers killing each other off again? As they always should. In this particular one, do you see that the cancelling is the h's? And so I'm left with the limit as h tends to 0 of this guy, which I can now plug in 0 for. So it becomes a square root of 4 plus 2, which is a quarter. So the slope of this function, the square root function, which probably looks something like that, x equals 4. That tangent line, that guy there, will have a slope of a quarter. Now, if I'd chosen an ugly number like 7, do you know I would have got the exact answer? Right? It might have been 1 over 2 root 7 or something, right? It would still be the exact answer. You couldn't do that numerically, because numerically you would just get some weird decimal, and nobody would be able to tell me that that weird decimal was the same value as 1 over 2 root 7, right? Because it would only be a decimal estimate anyway, right? And you see, this technique now gives you the answer, even although we haven't done it yet, even if the answer is really ugly looking. You know, you're going to all say hi and don't bye-bye quite yet, but almost. I've sent you out your reports. There was a slight typo, but not a major one, where I forgot to put in one of your homework grades. It was counted in the spreadsheet, so your grade is accurate. If you can't remember what it is, you could go over and write in your own number. You can go into WebAssign and find it. If you didn't get it, then you need to shoot me an email, and I will use the email that you give me and replace it in my spreadsheet, and then I'll send you it out so you can see what your grade's like. You will also find that the solution to that test is now online. So if you got anything wrong, if you wonder why I got 82 and, you know, where did I go wrong, you could have a look at it, and basically whatever you got wrong cost you the points that you lost. I mean, if you really want to know why, how many points did I lose for this and how many points did I lose for that, I could certainly tell you. But that would take a horrendous amount of work if I had to send everybody a list of what points they lost in which question. I've got it in a piece of paper, but that's not much use to you. And I can't send it because you would see everyone else's answer as well, what they got wrong and how many points they lost. And you don't want that. Okay, that's us. Bye-bye. I'll hang about if you have a question. I think we learned some cool stuff today, didn't we?
Yeah.
We finally got to do calculus. We actually finally got to find slope of a tangent line.
Imagine that.
And it only took us 3 weeks.
Yeah.
Thank you. Have a really good
Thank
day.
you so much.
You're welcome. Bye-bye, guys.
Thank you.
Professor Robertson, I actually
Yes.
have a question.
Yes, Mia.
One, it's on the WebAssign for number 24.
24 from what section?
2.6.
2.6. Give me a minute and I'll go hunting for it.
Okay.
Unless it's something you can read to me quickly.
I don't think I could read it clearly to you.
Okay. Then I'm gonna have to load it up. It's not a big deal. I can do it. Well, I should be able to do it. I've just got Windows in the way. Okay, finally got to where I need to be. Stay signed in. 2.6. Found it. Let's go. Well, I can just do a general version of the question. Right.
Yeah.
What number was it?
24.
Okay. So it's really, oh, it is. It's the ultimate. It's the last question. Is that right?
Yes.
Okay. Let me put it on the screen so we can talk about how you would solve it. we did something sort of a kind of like it.
Yes.
Okay, are you seeing it when I do that?
Yes.
Okay, so there's an e to the 2x and there's an e to the negative 2x, right? And that negative 2x might be the thing that's distracting you, right?
Yeah.
Ignore it.
Okay.
Think of it as e to the 2x take away 5 and e to the 2x plus 5, right? Something like that. So
Mhm.
what you would do is you divide everybody here by e to the 2x. So I'm now going to now move over to the white screen and show you that happening. So we have got the limit as x tends to infinity of e to the 2x, take away e to the negative 2x. This is the original question. E to the 2x, add e to the negative 2x. And I'm going to divide top and bottom by the biggest power. And essentially e to the 2x is the big power, right? E to the minus 2x is like 1 over something. It's very tiny. So what does this turn into? Well, there's a little bit of algebra issues, but hopefully not too much. That gets you 1. If you divide this by that, you actually get e to the negative 4x. Are you happy about that? That if you take e to the negative 2x and you divide it by e to the 2x, you're really doing e to the negative 2x over e to the 2x. Top guy take away bottom guy, you're getting that. Okay. Now, if you do the other one, you get that. And now I'll do brute force. And I deliberately put it in a funny way. That guy is weird. So let me show you who that guy is. Isn't that guy the same? That guy.
Yeah.
And what's e to the power of infinity but infinity? So that makes it 0.
Oh, okay.
So the answer is 1.